this is basically ICs, integrated circuits. So what is integrated circuits basically? I never want this one to finish early. No problem. So what is the integrated circuits? So basically we have seen, like in the previous chapter, we can design a complex circuit which can have different components. We can connect them together. So what is a IC basically? IC integrated circuit is that circuit can be designed on a single what you call semiconductor design chip, which in short we call ICs, integrated circuits. What is basically integrated circuit? These are usually called ICs in short, and popularly known as silicon chip because it is made up of silicon semiconductor. Computer chips or microchips, most commonly known names are here. So it is something look like that. It has legs here connecting pins which can be placed on the breadboard. You people are using breadboard, right, in the Tinkercad. So yeah. This is design, standard design basically, and the legs, gap between the legs is standard, so which can be placed on the breadboard easily. You can fix it over there. Now internal diagram is always available online, like each and every IC has its own number. When we search for the data sheet, you can find it and you can check it which particular pin is related to the input and output, power supply or ground, and lot of information will be there basically. And the circuit is inside that one. Okay, so it is ICs are designed to perform a specific task basically, and it's not a general purpose. It is like we are having a circuit which we need to use again and again, so we place it inside it and we can use it. So actually it is started early 90s, 90, 70, something like that. ICs invented, and at that time designers were able to design around 100 circuits or 100 component on this one. On the size of the chip, again it's 1 centimeter something. So basically the classification of these, we use the transistor, in order to explain how many transistors are there on the IC. So its era is basically classified depending upon the number of transistors are designed on this, inside the IC. So what is transistor now? As I already explained to you about the PN junction diode. So this is P semiconductor, this is N semiconductor. We know that PN junction diode is a two-terminal device where we have two terminal, anode and cathode, right? So actually this is about chapter 16. Chapter 17, which we skipped, it is, we will learn there later on after this about the transistors. So transistors are basically having 3 layers rather than 2 layers. Transistor consists of 3 layers. It could be like sandwich, so P and P, or what could be their possibility? N layer, P layer, and then again N layer, NPN. So transistors are of 2 types. So it is a 3-terminal device basically, 3-terminal device, right? So it is called emitter, it is called collector. We will explain this one in chapter 16, but giving you idea what is a transistor basically. This is base and this is collector. So as we know that diode working, so similarly we will be studying this working of the transistor. So the main application of the transistor is, again, it can work as a switch, like diode can also work. It can work as a switch, as well as transistor can also work as an amplifier. What is amplifier? A device which can boost up the signal strength, which is called amplifier. So we will go in detail there. So again, you can see both are of semiconductor material. So it can be designed on the silicon wafer because silicon is a semiconductor. So we can so always ICs are classified according to the number of transistors we can make on a small chip. This is about some introduction. Now we see more detail. So ICs, tiny electronic circuits used to perform a specific electronic function, such as amplification. Because there are many transistors inside, it is used to amplify the signal. So one of the example of the FM radio, which you are using in your car or somewhere. So you can just tune to particular frequency. Now you can increase the volume, increase the sound. How you can do this one? There is a requirement of the amplifier which can increase the signal receive signal, which is low voltage, where it can make it high. Strength can be increased by the amplifier. It is usually combined with another component. So IC itself not a complete circuit. It needs further components to make a complete system. So it is usually combined with other component to form a more complex system. So it's just showing here transistors. We here amplify the sound. So several hundred identical integrated circuits, ICs, are made at the time on a thin wafer. So we basically have a thin wafer of silicon, and on this wafer several hundred IC can be fabricated, so several centimeters wide, and then wafer is subsequently sliced into the individual ICs called chips. So later on we cut these chips. Can you just see this one small. So several hundreds we can find it, and we need to cut it down. Now again they are showing here, so many chips are there. Then later on it is need to be cut, and then it's just provide a packaging from the top, and then it can be used to integrate any chip, any circuit basically. So this is basically ICs. So type of the ICs now was, as I just mentioned, in the early days, the integrated circuits, only few transistors could be placed on a chip. As the scale used was large because the contemporary technology. At that time we have an old technology, the size of the transistor was very large, so very few component, very few transistor can be fabricated on a tiny chip. But as the technology advance, so what happened at that time? Due to the technology advancement, we were able, designer were able to design more complex design, more transistors can be fabricated on the tiny chip. So starting with the few numbers. Now, can you guess how many transistors can be designed on the chip, this small chip? Any idea? Which started with few transistors. If I ask you girls, what do you think? How many transistors can be fabricated now on this IC? Any idea? Any guess? So many, a lot. Okay, idea number, some numbers.
Millions.
How many? Millions. No idea. 100. C. How many? More than billions on a small chip. Do you know the configuration of A14 bionic chip which is coming in the iPhone nowadays? iPhone 12. If you just Google it about this one, A14 bionic chip configuration. So maybe we can find something I can show you. Yes. Can you read it? That is A13, 8.5 billion, and in this 14, I believe, C, 11 trillions operation per second it can perform. And what is that? And see the fabrication process. It is 5 nanometer fabrication process. Yani the size is very, very small at that time. And the transistor count has increased to 11.8 billion. See, this is 14 bionic chip which is the latest one available in the iPhones. Snapdragon, another Samsung, and also they are designing that one. It is almost equivalent to that one. So 11.9 billion. Previously that was, which is here, 8.5 billion. So this is the technology. That's why we people are enjoying the super fast speed, 5G and all, because of circuit is very small, very tiny. Components are so close to each other, even we cannot see by naked eyes. Never possible to see 11.8 billion transistors on a small chip, and which is very, very small. The size, if you look, the size of this one, which is designed on the 5 nanometer process, which is very small. And see, the processor is 88 millimeter square. This is the size of this chip. 88 millimeter, even not a centimeter square, 88 millimeter square. So this is the technology, and it is mentioned here. See, 11.8 billion transistors. Speed is also there. Feature size 5 nanometer. Operating frequency, it's mentioned here. So this is about the technology, and far away beyond the imagination. And you cannot even think it much is possible. So these things started with a few transistors. Now we are 11.3 billions. Let's see in the future. So this is all about. So over that time, millions and today's billions of transistors could be placed on a chip, and to make a good design become a task to plan thoroughly. This gave rise to the new design methods, basically, right? So now, well, so this is the starting, as I said. So it is started with SSI. What it was that? Small scale integration. So designers were able to design up to 100 electronic components. These are maybe diode, transistors, and electronic components per chip. Then MSI with the time change, so it just come with MSI. So designers were able to design 100 to 300 electronic components per chip. Then LSI, large scale is integration. Here 3000 to, you can see, 100,000 electronics component per chip or transistors per chip. Now very large scale integration, which is 100,000 to 1 million. Now ultra large scale integration, where designer can design 1 million electronic component per chip. And now we are beyond that one. Yani we are talking about very large, ultra large scale. ULSI, we are beyond that one. That is 5 nanometer design. So billions of transistors can be designed. So these full forms you should know. Okay, what is SSI, what is MSI, and all these things. So classification, girls, also. So integrated circuits can be classified in 3 categories. The one which can process analog signal, another kind which can process digital signal, the third one which can process mixed signal, yani both analog as well as digital, same inside the same chip. So this is the major classification of the IC. So these are some advantages, girls. Advantages: very small size, low cost, reduced power consumption, very less power consumption, because signals need not to travel very far. All components are very close to each other, so power consumption is very, very less. Highly reliable, higher operating speed, reduced external wiring connections. Definitely already too much connections are inside connected, so reduced external wiring. Easy to use, just put on the motherboard or the blackboard, that one breadboard, and just use it. So these are the advantage. All advantage you must know, because maybe asked in multiple choice question, which of the following is an advantage or not an advantage. Similarly, we have some disadvantages as well. So disadvantages are, you look here now, if one component in an integrated fails, it means the whole circuit has to be replaced. This is the problem. Yani inside millions of transistors, if one transistor fails, so it will start malfunctioning, maybe it will not work. So we cannot fix that particular component, particular transistor. We need to replace the whole chip. So this is the disadvantage. Second, it is impossible to fabricate transformers. You know the size of the transformer is very large, and we cannot design transformer inside the IC. Also inductors, capacitors. Capacitors, any small capacitors are possible, but large capacitors are not possible. So this is another disadvantage. So integrated circuits have limited capacitance, as I just said. So low value capacitance is possible when we need the large value extension. Okay, we need to have an extra external capacitance. So like you can say, transformers, inductors, capacitance cannot be fabricated inside the IC. Only the component which is designed from the semiconductor devices. Power that integrated circuits can produce is limited. So again, power that it can produce is again limited. It cannot produce high power. So whenever we need a high power, we need to have external components rather than we can rely on integrated circuits. So one of one disadvantage. Integrated circuits are not flexible. Yani the circuits is actually designed during the manufacturing process, and it is inbuilt. Later on we cannot change anything, we cannot modify anything, so it is not flexible, it is rigid basically. So integrated circuits are not flexible, their component cannot be modified, and neither can be parameters of the operation basically. So these are the disadvantage of the ICs technology. Next topic is here, which is optoelectronic devices. So there is a word opto, there is a word electronics. So optoelectronics is a combination of optoelectronics. Did you heard this word somewhere? Opto electronics? Yes, definitely. What about the opto or similar word? Opto.
Like optimize?
Not optimize. Try something else. Opto. Okay, what does the meaning of opto? Yeah, optical. Have you heard optical?
Yes.
Yes.
Everyone is having internet connection at home. Which type of this internet you are using? Optical fiber.
Optic fiber.
So what is optical fiber? Do you know how it works?
Yes, it's made of glass and it transports signals.
True. Oh yes. So how the signal travels? Which type of signal travels inside the optical fiber? Electronic signal, electrons, or any other thing? This is right what you said. It is made up of glass, silica. But what about the type of signal which can carry in this? Which type of signals can carry?
Very light pulses.
Light pulses. True, correct, very good. It can carry light pulses, light signals, and you know that light signals cannot harm you. So even you can touch that wire easily. Okay, you can bend that one. Bending is again possible, and it is so durable. Once it is fixed, do you know the life of that optical fiber? It is around 40 years. The life, so it's so durable also, and free from hazards.
We don't know what is the optical fiber.
You don't know where is the optical fiber? Okay, if you have this internet connection at home, STC, definitely you people will be having optical fiber, connections. So there is a wire, very tiny wire is coming from the outside box and connected to your router. You go and check it there where it is connected. So for me, I don't have optical fiber here. STC not giving. They are saying near to your area we don't have this optical fiber. So we are using another one, and that is DSL connection. But usually optical fiber you can find it. Okay, so what is the meaning of optoelectronics? So it is a field of study where we study the interaction of light. So opto means light, girls. Optics, light, and electronics is basically electronics is flow of current. It's all about electrons. And do you know the basic element of light is called photon? Light element, photon.
Yes.
Like similarly, current element we call electrons. So this is the field of study where light interact with the electrons, or you can say photon interact with the electron, and electrons convert into photons, vice versa. You know, this is optoelectronics. It is a field of study where photon interact with the electrons and electron interact with the photons. So there are devices now, we will look into it. So what you will be learning in here, introduction to optoelectronics, which I already given you, optoelectronic devices, optical communication, advantages, and summary we will be covering here. Now, so introduction of optoelectronics. Optoelectronics is a study and application of electronic devices, okay, that source, detect, and control light, usually considered a subfield of the photonics. Optoelectronic devices are electrical to optical, yani you can say converting what, electrons to the photons, or optical to electrical. Transducers, yani converter, they can convert light element, yani photon, into electrons and electrons into photons, or instrument that uses such devices in their operation. So optoelectronics is an often anonymously used as a synonyms, yani electro-optics, we also call that one as a synonym, but but is in fact a wider branch of the physics that deal with all interactions between light and electric fields, whether or not they form part of an electronic devices. So, image of optoelectronic devices, right? Have you seen the LEDs? LEDs, small LEDs, light LEDs. There are a lot of LEDs in your daily life. You can see in the TV, you can see in the microwave, in the remote control, a lot of places you can see, right? Yes, LEDs. So how LED works? Do you know? Yeah, LEDs are everywhere, you know. So how LED works? Even the room lights also LEDs. So how it is working basically? So LEDs are everywhere, but you know how LED works? For that, we need to provide the current in order to glow the LED. So we provide current. When we provide current, basically electrons are there, right? And when the current we provide to the LED glows. So what it is emitting? It is emitting photons or not? So LED is what? What it is doing basically? It is converting electrons into photons. I say like this, correct? Getting the point? So LED is very common. We all know that, yeah, photonics. So it is converting electrons into photons, simple. So we know this one. So it is image of the photoelectronics. We can see this one. It is, you know, it is basically used to, LED used to LED, and even LEDs are there in your mobile devices, in the TV, everywhere, panels, LED panels everywhere nowadays. Because of LEDs are durable, it consumes less power, and it is more brighter. So important optoelectronic devices. So LED, what are the different optoelectronic devices? LEDs are there. So we discuss LED. Photodiodes, which, you know, perform the reverse operation. So basically we can say LED is converting, you know, to photons. Understand? We use HNU for a photon H. And this one is the opposite. Yani photon to electrons. This is sensors which sense the light. It takes the you know, light and convert into electrons. Another is photovoltaic devices like solar cells. You know about the solar cells. So we'll discuss also, right? Nowadays, you know, these are non-conventional energy resources, and all the countries are looking for this solar panels, solar light, you know, solar systems everywhere. And the fourth one is the laser diode. So we will discuss all four optoelectronic devices one by one. So LED, do you know what is the full form of LED? We know LED, but what it is stand for? It is a acronyms of light
emitting diode.
emitting diode. So diode you already studied. Okay, but there is a special arrangement here so that it can emit the light. So this is similar to the diode, and designing is almost similar except some changes. So see now, so how diode works, you know that it works in forward bias, right? Similar way, LED also works in a forward bias. I showed you LED. So there are two pins, like one is short, one is long. I told you this is positive terminal. If you remember, I said this is negative terminal, right? So it's like a diode. But you know, some special thing is there. We provide here opaque region, yani some region transparent, so that see what will happen now, guys. So when I connect to the forward bias, when I connect to forward bias, so what will happen? Electrons and hole, they combine in this depletion region. We know that when they combine, you know, they release the energy. Getting the point? They release the energy. That energy basically in the form of photon. So if we provide here opaque region, transparent region, so this energy come out basically, or we can say photon can come out. When they come out, basically they emit the light. This is something, this is the concept. So this is LED. It is P type is there, N type is there, but depletion layer is designed in a way basically. So recombination of free electrons and holes are happening here, and they are releasing the photons here. So emitting photons or emitting light. This is something basically. So this is the concept of the LED. Now how it is designed. So we used to have a substrate on which we, you know, design P and N material, you know, types. So this is substrate. Then on it we have N type. So N type have more whole electrons, we know. Then we have active region. Yani this region is intentionally leave open here so that here we can give a chance to recombine the electrons and hole, and the energy can come out basically rather than containing inside of just diode. Because it's LED, so we have transparent, yani electrons can emit here. And this is the P region where we have more holes. So this is basically the structure of the construction of the LED. Now, you know that LEDs are of different colors. It could be like, you know, white, green, blue, different colors are available. So depending upon the material in which we are using, we are not going to use silicon, germanium all the time. There are a lot of combination, germanium phosphide, arsenic phosphide, a lot of combinations are available. So depending upon that material and the frequency wavelength of the photon they are emitting, different colors they can emit basically. And now coming to the symbol of the diode LED, it is very much similar to the diode except these arrows. Can you see this one? Arrows which are going outward, showing that it is LED symbol. Clear? This is the change. So everything is same except the arrows. So you don't forget to mention the arrows, because arrows are saying that this is a diode, but it is light emitting diode which is emitting the light. All right. So this is all about the LED. So you can just read it down, just, you know, have a concept of it. All right. Now, next is photodiode. Girls, as I said, it performs the opposite operation. All right. So I'll show you first a video of it because I don't have this device with me. So at least I can show you a video. You can go, YouTube yourself, check on YouTube. There are a lot of, but I'll show you this one. So see this one. This is light LDR photoresistor or light dependent resistor. There are a lot of names for this device, photoresistor, LDR, light dependent resistor. See how it works basically.
Right. That is why they are light sensitive devices.
Sensitive, they can sense the light.
They are also called as photoconductors, photoconductive cells, or simply photocells. They are made up of semiconductor materials having high resistance. There are many different symbols used to indicate an LDR. One of the most commonly used symbols is shown here.
Now arrow is inside.
The arrow indicates light falling on it. Now come to the working principle of LDR. Resistor. A light-dependent resistor works on the principle of photoconductivity. Photoconductivity is an optical phenomenon in which the material's conductivity is reduced when light is absorbed by the material. When light falls, that means when the photons fall on the device, the electrons in the valence band of the semiconductor material are excited to the
So they are
conduction
basically
band.
electrons which are in the valence band. They have low energy. We know that conduction band is the high energy state. So what allow here to come, to come the light, to fall the light. So when the light comes here, any photon gives their energy to these electrons. When these electrons get the energy, they get excited and they jump to the higher energy band. What he's explaining here.
These photons in the incident light should have energy greater than the band gap of the semiconductor material to make the electrons jump from the valence band to the conduction band. Hence, when light having enough energy strikes on the device, more and more electrons are excited to the conduction band, which results in large number of charge carriers. The result of this process is more and more current starts flowing through the device if circuit is closed, and hence it is said that the resistance of the device has been decreased. This is the most common working
Maybe I
principle
can
of
show you
LDR.
some what you called.
Now, we will try to give you some idea about characteristics of LDR. As we told earlier, an LDR is a light-dependent device whose resistance is decreased when light falls on it, and that is increased in the dark. When a light-dependent resistor is kept in dark, its resistance is very high. This resistance is called...
Yes, Bayan, it's correct.
It can be as high as 10 to the
So
power
you
of
can
12
see this one
ohms.
lot of places, not only here. Okay, one of the example I'll give you. Do you have mobile phones? And there are, one sensor there, near to the camera, front selfie camera. When you bring your hand there, you can see that your mobile screen will turn off automatically. So what is that sensor? That sensor is sensing the presence of the light. When you put your hand there to cover that sensor, basically screen will turn off quickly. So these are the sensors, basically the sense. Even another sensor itself, the TV sensor. You have a remote. When you press a button, it is emitting a light basically, but it is not visible light. So, but there is a TV is sensing that light, and based on that, it take the action. Also in the street light, those are automated now. So we fix that that the resistance when there is a dark, automatically the sensor sense that presence that there is your light is very less. So at that time the conductivity, basically with the bright lights, we can say it increases. So it basically turn on the lights over there. So I can show you this is actually yes LDR. Actually is this one.
Good grammar and spelling are important, but if you want to write essays that inspire,
Hello once again, and welcome to Simply Electronics Basics 26.
So initially,
I'm going to be talking about this
very high. Yani it will not allow the flow of current. But when the light falls on it, the resistance reduces and current can pass through this.
One component in front of us, and this component is a light-dependent resistor, otherwise known as an LDR or a photoresistor. There are many different types of photoresistor, but they will generally have this kind of look. The clue as to what they do is reflected in its name. It is a resistor that is light dependent, and what that means is that this is a resistor that changes its resistance depending on the amount of light that hits it.
I want to show you basically a project. Project based on LDR. Okay, see this one. You can see this one, this person, or this one. So if you see this one, as the light, LED is glowing. When you turn on the room light, LED is off. When you turn off the room, LED is off. See now, on, off. So basically this is the LDR, which is sensing the presence of external light. You can design this one yourself, it's so simple. You can go visit the Huber. There is a electronic component shop. You need to bring this LDR, 2 resistances, 1 LED, 1 transistors. And you can find everything online, how to design everything. And everything is available through that shop. Their shop is so cool. Even I bought a lot of components from there. So it's Huber. Maybe exactly I can tell you if you want the you call it address. You can go and check different colors of LEDs and all. So how cool this one, you can see this one. So what it needs, a battery, simple resistances to control the current. So inshallah I'll share you. So during any weekend, during your summer vacation or something, you can try. If you want, no, you can try. I need to search his names, that name I will provide to you. So this is resistances, value is already showing here. And also, you know, it's not just you can turn on the light, you can turn on the alarm. Yani you are sleeping, if someone come to your room and turn on the light, alarm start ringing. So you can say when someone is enter and something, you know. So lot of you know, applications are possible. This is transistors. We are talking about transistors, right? This is a 3-pin transistor, which is 547, which is used to amplify the signal basically. Now this is breadboard. This is called breadboard. So it is also available there. So it's like that, you just need to connect accordingly. It's connecting all. So I can show you quickly. And see, this is the actual circuit. Yeah, it will show the circuit diagram which you need to design here. This is LDR connected in the circuit. We used to have these, you know, projects in the beginning of the college, 5, 6, 7 years before. So students used to design this one. They used to bring all this component, design it in the lab. But later on, because electronics is not your major, so people said things updated. Now he is design almost complete, connecting all the component according to the circuit diagram. Once it is done, the finally battery is connected there. Just wait, I'm just skipping this part. So finally you can see. So this is one of the application for the light. So it is now giving power to the circuit. And you know now how to use breadboard, cutting circuit, internal connectivity. Yes, this is 9-volt battery now connected. So there are a lot of sensors. This is light dependent. We have a lot of sensors, temperature sensor, you know, proximity sensor. See, whenever it's covering this resistance is reducing and current can flow like this. So this is just sensor, LDR. So using, you can do a lot of things. So hope it is clear to you, right? So a lot of things you can find there. Maybe this is they are using to turn on this one. Maybe we have other things. So I pick one. So just to give you idea, you can Google it now for more information. Now let's back to this. And okay, so photodiode. Now I was explaining you photodiode, or in short we call LDR, light dependent resistor. What happening there? We have an open region here. We allow the light to fall on this area. And you know how it is connected? It is connected in reverse bias. This is interesting thing, reverse bias. So that depletion region is more widen. So when we apply reverse bias, depletion region more widen. So exposing a semiconductor to a light can generate electron hole pairs. So when this, you can see green, this is the photon striking over there. So it gives the energy, and what happened? Electron hole pair generated. So this is positively charged. So electrons start moving here, and the hole start moving toward this positive. So that constitute a current basically inside this one. And at that time, circuit can turn on, turn off. So here the arrows are inward. It is because of the light is falling on the diode. So it is again a type of diode, but it is a photodiode which can sense the light. So photodiode is semiconductor diode that can function as a photodetector in the PN junction or PIN structure. It has two structures, either PN junction or PIN structure. Do you know what is PIN? Any guess? P-type material and N-type material. And you know what is I? Intrinsic. I told you semiconductors are intrinsic and extrinsic type. So intrinsic is a pure semiconductor, right? So it is a pure semiconductor. So we use P-type plus pure semiconductor and N structure. we can design this turn. So when a photon of sufficient energy strike to the diode, it excites an electron, thereby creating a mobile electrons and positively charged electron hole. And this is the concept of working a photodiode, and this is the symbol. Okay, a photodiode can be operated in one of the two modes. One is photovoltaic mode or photoconductive mode. Photovoltaic is what? In photovoltaic mode, the photodiode is unbiased. Look here. In photodiode, yani photovoltaic, it is unbiased. Yani we will not connect any external source. Yani it just connected there without any external battery, rather reverse or forward bias. In other words, no external voltage is applied to the photodiode under photovoltaic mode, which is the basis of the solar cell. The same concept we use in the solar cells. Another one is photoconductive mode. So in photoconductive mode, an external reverse bias voltage is applied to the photodiode. So these are the basic points which you should keep in your mind when you prepare yourself for the examination. Key difference between LED and photodiodes, you can see now. So based on the function, because this is LED, the function is different. It converts electric energy into light energy, and it converts light into electric. And you can read it down, all these things now. Next is what? Photovoltaic device or solar cells, girls. Solar cell. It is most commonly used, and you can see a lot of places in your university, in the park, in the street light. So these are the panels. So what happening whole day, we know that sun light is basically free of charge, and alhamdulillah is available over the world everywhere and free. So all the countries are looking to utilize this energy. So there are the panels which basically take this energy and convert it into electrons, electronic energy, and we have a battery which can be charged during whole day. At night that battery charge lights basically give energy to the LEDs, and that close at night basically. Nowadays these panels are integrated on the roof of the houses, especially in America, where the villages are far away from the urban cities, and light cannot be cannot be reached there via wires and all. So these things are there so that that house can get energy whole day and can charge battery and utilize at night as well. In India also we have a village basically that is completely running on the solar energy, even for the irrigation, for the pumping and the pump, lightning and fans and all run on that one. So how it works basically, the photodiode devices or solar cells are semiconductor PN junction that can convert solar radiation to the electrical energy. So this is a single cell, girls, which can sense the presence of light, and this is a module which is called module. There are many cells there. Then this is called panels. So there are modules, then we have panels, then this is called arrays, and these arrays are integrated over the roof basically, or even in the window, window glasses. So how it works basically, so energy is falling on these cells, and there is an energy conversion. So this light energy is converted into electrical energy. Then we have energy conditioning. Then we connect a storage, could be a battery and all. Then from that storage we can utilize this energy, which can use to light for the lighting purpose or electrical utility purpose. This is energy distribution later on. So this is basically the concept of the photovoltaic cell. Okay, is it clear? Concept is clear to all of you? All right, so just it is the information and you need to read some things, but here, important point. Next and last one is the laser diode, girls, and you know about the laser. Laser is an acronym of light amplification by stimulated emission of radiation basically. Okay, diode, it is again a diode, but laser diode. Concept: for atomic systems, the thermal equilibrium emission of light is result of two main processes. What is that two main process? Which is called absorption of energy, spontaneous, and the third mechanism is basically crucial to the formation of laser action, which is we call stimulated emission. So light amplification of stimulated emission radiation is the laser basically. So what is absorption? What is spontaneous emission? I believe you have studied these things in the physics. Do you remember Balmer series, Bastian series, and one more was there, Lemon series, right?
Yes.
What happens there basically? Yeah, you studied in the physics. So it is like what, you give the energy to the electrons in the lower energy band. Once they receive the energy, they jump to the higher energy band, and they cannot stay there for a long time. They come back. When they come back, they release a different type of wavelength photons basically. This is that concept. So now you look here. So photon emission process. First is what? Absorption. What is absorption? Yani photo detector, what happened? Electrons is there in the lower energy state, and what happening? A photon of energy h nu strike on it, and it gives energy to it, and once the electrons get that energy, it reach to the higher energy state basically. So this is the concept which we use in a photodiode, yani it provides the conductivity inside the device basically. Another one is called spontaneous emission. What is spontaneous emission, girls? Spontaneous emission is that, we provide the biasing. Already I explained to you, external battery. So once you provide the biasing, what happen in the LED? Already electrons get more sufficient energy, and they reach to the higher energy state. And this is the tendency of the electrons, girls. They cannot stay in a higher energy state for a long time. What happened? They fall down or come back to the lower energy states. When they comes down, they release their energy. And how they release the energy? In the form of photon of the wavelength h nu, which is basically a difference of this energy band. So this is the concept which we use in LED. Now, this is the laser. What we do in the laser, girls, because here we use stimulated emission. Stimulated emission is what basically? Here we have mirrors connected there. And we know that, so here we already, pump the electrons, and they are in the higher energy state. When they fell down, so here because we have mirrors here, so once they fall down, they release one photon, and that photon is basically strike on the mirror and come back, and mirror and come back. So it again, one photon, we can say, produces 2 more photons, and these photons further produces 4 more photons. Yani it's keep on doubling. So because of what happened, this laser is more pointed, more coherent, and it can, travel to the long distance. Have you used a laser diode ever? Maybe during presentation, if you have presenter, girls, we used to have that pointer which can point on the somewhere during presentation. This is the point and all. Yeah, so that is a diode basically, which is the advantage of the laser diode is that it is more coherent, more directional, more sharper. This is something basically. So it is a concept of a laser. And do you know laser applications? A lot of application nowadays, especially for the skin treatments, even for the eyes surgeries. Once if someone is having eye problem, or their issues is there, so yes, it is used to treat the eyes, to set the focus of the eyes. Also for the skin, people used to remove the hairs, or used to remove the pimples or something. Even in the CDs, in the CDs, have you heard the name Blu-ray disc, which is more commonly used if you have PS4 or Xbox. It all uses Blu-ray disc. So Blu-ray, why the name is Blu-ray? Because the technology used there to write the data is basically blue laser. That's why the name is given Blu-ray. Yeah, this is a lot of things. So that's the name is Blu-ray. So let's see some of the application of the laser. And one more application of the laser. Laser can cut a metal itself when it is high energy. Laser, have you seen the movie? I don't know how many of you watched the movie. What is that? Final Destination. Maybe someone watched. So then Final Destination, I think 3rd or 4th, there is a scene. One lady went to hospital for the eye surgery, and what happened? Mistakenly, the doctor increased the power of that laser, and he just involved other work. So, but she was tied on the what you call chair and something, and she cannot move. So that laser cross her head and divided into two parts. It's like that. It's a movie, but it was just giving you idea. Yani is so strong. Yani high power laser even can cut the aeroplane. So it's so dangerous and definitely can be used for tool cutting. Tool shaping is used like. Yes, so very difficult. So let's see some of the advantages and application of the laser here. You can see now. So this is the disc I told you, and also laser diode have been used for cutting, surgery, communication, also optical fiber communication. As you people said, we have optical fiber. So optical fiber, how optical fiber is working basically? Optical fiber is working again with the concept of laser signal transfer there. Just a minute, guys. So optical fiber, we know that it is made up of silica, but how the signal propagate inside? Signal is basically propagating like laser signals are there. It can propagate there. And see, this is the laser lights also. So one end if we open of the optical fiber, and another end if we just give the laser, so it can travel long distance. This is also there. So writing and reading, etc., is all examples of this. Advantage of optoelectronics, girls. So compared to copper wires, optical fiber cables cost less. Is basically what is there? Why there is a chicken with laser eyes? Where is a chicken? I did not see. This one? Yeah. Yani, you know what they are trying to say here? It looks very soft, very cute, but it is so dangerous. Angry chicken, yeah. Like angry bird, now we have angry chickens. So it looks very easy and very cute, but it's so dangerous. Cute in the sense we can have laser light at our home and like even you have seen some devices are there, girls, for the home. If you turn it on, there are stars and smiley face on the wall during parties and all. We use that one, right? Toys itself. So this is something. So it looks so easy and it's so soft, so delicate. On the other hand, it's so strong. It can cut the things as well. So maybe chicken with laser. I don't know. Miss Mavish put this one. I don't know the reason. She is the coordinator. Yeah. So maybe it's a chicken laser. So advantage of optoelectronics. Compared to the copper wires, optical fibers cables cost less. Cost less. Why? Because once you purchase, as I told you, it can long lasting up to 40 years. So that's why cost less. Less weight. Weight is so less and provides more bandwidth. Yani high frequency signals and many signals can travel at the same time. Maybe you have noticed this type of optical fibers, and we are giving a light here, and on the tip, this light is glowing here. So there are a lot of applications nowadays available to basically decorate the home and all. So they isolate one electronic component from another and passing data. So that you cannot touch any wire, naked wire, electrical wire, because it's so dangerous, hazardous. See, actually, we see other type we use for the electrical purpose. Understand the point? So for the electricity, we cannot use these wires. No, because we need electrons. So we need to transfer the electricity, high power current. So we need to use the copper wire for that purpose. But like, the information, the data which you use to transfer information, we have a modem that convert your data into the basically 0-1 binary. And from that 0-1, we have a laser which modulate basically that data. Then we use it. So all the communication we cannot use laser, but there are some which we can use basically. It was also used to, measure the distance between the two aircrafts. One is running far away, so how far they are. So one aircraft can send the signal to another one, and because laser is 4 directional, can travel, kilometers. So it can touch and come back. So then we can measure that distance also, how far one device from the another, object. This is also used. These are some, okay, so they can react to the light and change electronic data. All right, remote control and all these we have. Okay, so now what is there? But so finish, we have done with this one.